Hey everyone, welcome to our webinar on Advanced Installer QAM automation through PowerShell. We have some really cool stuff to show you today. I'm Gabriel. I am joined by my colleague Alex, and together we will be your hosts for the next hour. This is where we get to show you how to use Advanced Installer to automate your CI/CD packaging workflows and running them in Azure DevOps. We'll have a few slides to tell you where we are, but mainly there will be lots of live demo goodies. Keep in mind that during the demo, there may be some hiccups with it being a live demo. There are always unpredictable things that may happen in such an environment that involves complex systems and a lot of attention. If such hiccups do occur, please bear with us as we get to work in finding solutions for them. Let's take a look at our agenda here. First of all, Advanced Installer makes you more productive, and we'll have a look at how that productivity can be unleashed in an automation environment. We'll see some 101 about Advanced Installer automation, and we will explore the two major ways on how to accomplish automation in Advanced Install. Afterwards, we will dive right into a live demonstration. My colleague Alex will take us step by step on how to package a C#.NET application using the COM interfaces that Advanced Installer offers, and running those operations in Azure DevOps. We'll get to see cool stuff like package creation, file modifications, digital signing, and how to retrieve your built packages through artifacts. Because what you get at the end of all this is a packaged version of your application that is ready to be installed, but you need to retrieve that package. So lots of cool stuff to go through during this hour. At the end, we will take a few minutes to answer your questions. So please write them as this presentation proceeds. All of us here love Advanced Installer. It's quite simply the best packaging tool out there. But even though we strive to offer a well thought out graphical user interface that is as intuitive as possible, there are scenarios like automation where a GUI is not needed at all, or maybe it's cumbersome for us, so it's best to be avoided. So this is what we want to check out today. No graphical user interface, not for today. We're going to talk about how Advanced Installer enables you to automate your package needs. The functionality that Advanced Installer offers can be automated in two major ways. The first one is through the command line interface, or simply said, the CLI, along with command files. We will immediately introduce those, and you will have a short description of what they are and what they do. The second way is through the component object model, or as everybody refers to it, the COM interfaces and objects. Both of them are actively supported by us, with the COM support being much newer. Our development team has put and invested a lot of effort in it for the past few years. And as of today, March 2024, the surface area that's covered for our functionality is approaching 100% parity. However, there may be corner cases where functionality that's present in the CLI is not yet exposed in the COM interfaces. However, like I said, those are corner cases, and if you encounter such corner cases, please let us know so that we may implement them using the COM interfaces as well. When it comes to automation through GitHub Actions or Azure DevOps, Advanced Installer offers integration with both of them. And here I'm referring both to the CLI and the COM interfaces. They can be easily put to work on these continuous integration and continuous development platforms. Our live demo today will focus on Azure DevOps, but please let us know if you in the future would like to see such a demonstration for GitHub Actions. Now, a quick mention of our command line interface, the CLI, what we support there. There is lots and lots to talk about this. We don't have the time in this webinar to do that. You can check out our user guide there at the link shown here. You will find lots of information about what operations we permit from the command line. Basically, there is an executable called advancedinstaller.com, and you can call it with a wide range of parameters to do the operations that you intend in doing. In this sample here on this slide, we can see that the first line is actually registering Advanced Installer using a license ID. So you don't need to open up the GUI to register the application. You can just run this command, it will be automatically registered. This is very useful in CI/CD scenarios where your pipeline will need to, every time will need to register the copy of Advanced Installer. The second example here on this slide refers to Azure Key Vault, which is a method of a digital signature for our packages. Advanced Installer allows a range of ways to sign your package. One of them is Azure Key Vault. Another one is using a certificate file, which Alex will focus on. And there are more that are available. But in this scenario, for example, when you want to set your key vault parameters, you can just call advancedinstaller.com, not the website, the executable, and give it the required parameters, and your project will be all set up to use Azure Key Vault. Now, on the CLI, there are you can quickly get into scenarios where there are more than one commands that you need to execute. So you would need to invoke this executable multiple times, and this leads to boilerplate, which we want to avoid. And command files are our method of doing that for the CLI. So the command file is simply a text file with the extension AIC, in which you write the commands you want to be executed. You have a prefix in the first line of the file should be semicolon AIC, and then the commands that need to be executed. In this example here, we have the product version that's being set, 2 files that are being added, and a property value that is getting updated, followed by the saving of the project and a rebuild operation. Quick and easy, right? So that was a quick introduction for our CLI support. Now moving forward to the really interesting stuff. The second and most powerful way of automating Advanced Installer is to use the COM interfaces. Now, why COM? Because it's universal and language neutral. It's not limited to the CLI like we saw before on the previous slide. You can call the COM interfaces from a wide range of programming languages such as C++, C#, or scripting languages like PowerShell, as we are about to see very soon. Once Advanced Installer is on your machine, you can simply use our COM interfaces from wherever you like. Programming languages, scripting languages, it's right there for you. These interfaces that we expose offer you more granular control than a simple CLI. You are in full control of what happens. And from PowerShell, for example, you will have access to the full breadth of .NET classes and objects at your disposal. So you are free to compose your script, and you can express a wide range of operations that otherwise in a simple command line tool, you are much more limited in what you are able to accomplish. Now, how do I get the CLI to work? You just call it from CMD or your preferred terminal tool. How do I get the Advanced Installer COM, the component object model interfaces to work? Well, simply it's basically the same. There's no difference. As soon as you install our product, once Advanced Installer is on your machine, it's ready to go. And regarding PowerShell, COM is a first-class citizen in PowerShell. It's nice and clean to use. You just instantiate a COM object and give it the prog ID Advanced Installer, and that's all you need to do. You're in. So this is where you are on automation, the gist of it. Now it's time to dig in and do a live demonstration. I will hand it off to Alex, who will show us how to integrate the packaging process for a C# WinForms application using the Advanced Installer COM interfaces. First, he will do so locally on his machine and step by step in order to build this script that will need to execute. We will hopefully get everything working without too much debugging. And then after everything is running, he will show us how to run it in the cloud using Azure DevOps. So Alex, please take us through the process.
Hello everyone. In this demo, I will show you a few tips and tricks on how to use and discover Advanced Installer PowerShell automation APIs and how to create, configure, and build a project from scratch. Let's share my screen before we get started. I already prepared a Visual Studio solution containing a .NET Windows Forms application that needs a service to be installed. If I see here is my project for the main application. Here's a library and a project for the service. Now let's build a solution on both configuration, debug, and release. Right now, we are on debug configuration and we'll build it. Okay, let's switch to the release and build the solution again. To write our PowerShell script, I will use Visual Studio Code. So let's launch it and create a new script file for our project. We select the language and save into our project folder. We create a new folder for the setup and save our script file. Setup.ps1. The first part of the script contains a boilerplate for manipulating paths and handling script execution from Azure and local machine. Just to make sure we will not face any problems, I will just paste the code into the script. As you can see, we have two arguments for our script. One is the configuration we want to package, and the other one is the path to the certificate file. If we don't have any configuration assigned, I chose a default value for it, release. The project directory is relative to the PowerShell script root, and we have two variables to locate the project output files for the configuration. And of course, if we don't specify any certificate file path, I will locate the one on my machine. That's how I'm managing local machine execution. Now we can start using Advanced Installer PowerShell automation. First, we must instantiate an Advanced Installer object, as Gabriel told earlier. So just define a variable. and specify the prog ID. Now, if we try to use advanced installer variable, we see that we don't have any type information loaded for our object. So if we call get member instruction, PowerShell instruction on that variable, we have nothing. But if we run the instruction, we can see now that we loaded the type information for advanced object. And if we try to use Visual Studio Code autocomplete, we can see everything works fine. And seems like the type information was loaded for this variable. We can create an advanced installer project. So let's put it in a variable. And now to create an advanced installer project, just call create project method from our advanced installer object. And we must specify the project type. To do that, we can call advanced.project types and select architect. If we run our instructions, we can see that our project is created and we can use it.
Can you show again, Alex, how you run a specific instruction?
Oh,
more
yeah,
slowly?
sure. I just right click and run selection, but I use the shortcut key. As you can see here, the shortcut key is F8. So the next step in our script is to configure the package digital signature. To do that, we can call digital signature property and enable signing. That will be set to true. We must specify that our certificate file is on the disk. So use file from disk, and as argument, we have to set certificate file path. As you see in the first part, we define a variable to locate our certificate file. Advanced Installer offers you multiple options to sign a package, but for this demo, I will show you how to digital sign package with locally stored certificates. Best practices recommend not to include passwords as plain text in the script. So we will use an environment variable project. We will set the password automatically, and we have to specify the password for the certificate. Using environment variables in PowerShell, we can, it's doing like this. So I already defined an environment variable for my certificate password, and the autocomplete works perfectly. Now we can run our digital signature instruction to see if everything works fine, since that we don't have any problems yet. Now let's add to our project the files that we need to be installed. We can do this by adding the entire folder where our solution projects were built. We can do this by accessing file component, and it has a method to add the entire folder content. Okay, so the first argument represents the project path, and if I hover on this function, I should be able to see the arguments. So the first argument is target folder, and the second one is the folder source path. Okay, now let's add this one. And for this method, the first argument is also the target folder, but as a string. So we can easily give this argument project. So cool project is the target directory in our advanced installer project. And the second argument will be the source file on the disk. And for that, we have a variable that we define above. Okay, let's put it in a variable. So let's call it project output files. And it will be an array of files. Let's add, let's execute. And for second part of our application, I'm referring to the service. We should do similar thing because it is built on another folder. So we have also a variable that we defined in the boilerplate part. And the target directory should be another folder. Let's call it cool project service. And store into a variable, a new variable. Output files. Okay, let's run again. I run every single time I'm writing a new instruction. I'll run just to be sure my script works well and we don't have a lot of errors. To see all the project files, we can inspect file property from project.files component. So let's run in the terminal. Project.files component.files. And we can see, we should see all. Oh, it seems that we have an issue with Visual Studio when listing, or I don't know, when executing in the current PowerShell session, they must have a problem.
And maybe
Yeah,
restart
let's
code.
try to stop. Yeah, I managed to stop this. Let's clear because and run again. Let's try to do filtering of those files, and I'm wondering if we added some symbol files. The symbol files usually have PDB extensions. Let's try. Okay, seems like we have 2 PDB files, or maybe three PDB files. Okay, but the problem is that we don't want to include our PDB files into the release folder. We might want them in our debug package, but we don't. I'm pretty sure that we don't want them into our release package. So let's check our configuration to see if it's released. And let's collect the PDB files.
So just make sure these are files that Visual Studio creates, right?
Yeah,
They are useful for
on the build
debugging.
process.
Yeah, that's why we don't want them on the release build.
Yeah, these files are used for debugging. Now that we collected the files to remove, we iterate that collection and remove each file. And for that, we will use the debug, okay, just to see how to call and what method should we call file. And for that, we can call again get member instruction. Okay. Maybe file wasn't assigned. Now that the file variable is assigned, we can we can inspect the information type for the file. As we see, we have a lot of properties that allows us to configure the file, and a single method that is called delete file. Calling this method will remove the file from our project. So let's go here, delete file. And after we run, let's take out the breakpoint and run the script. And if we run our filtering instruction, we shouldn't see any PDB files. All right.
Cool. So now we have excluded files that we do not want to be in our package.
Yes, only for release configuration, because it happens a lot of time that you want to deliver a debug package in order to investigate some bugs of your application. Now that we have added our project resource files, we can create shortcuts for the application. Let's find our application main executable, let's say, and put it in exe file variable. We do that by using a where clause, as we did for the PDB files, which can just copy and paste, but we have to specify the exact name of our exe, and we already know it. It is called, the file name is coolproject.exe.
I'm gonna jump in quickly, Alex, and mention that there's a typo on line 30 in the matching text for PDB. The dot
Yes.
star, they are reverse, so star dot PDB.
Oh, okay.
Yeah, just a typo.
Oh,
It was mentioned by someone watching, so
I'm not sure about that, but it's fine. Let's continue with identifying our main executable file. Here we want to select the first, so we have a where clause that returns a collection, and we need to have the first dash first. Okay, let's run it. We have a bug. Oh, this pipe, and first run again. We check our exe file variable, and we see that we found our coolproject.exe file in our project. We will create a shortcut into our application shortcut folder and another one into the desktop folder. So let's add a variable for the first shortcut. To create a project, a shortcut, we must use shortcut component property of our project and just create file shortcut that I should see which are what arguments. So we need the target folder, which is application shortcut folder, and our file. Predefined folders, and here I have shortcut folder, and the target file is our exe file. Run and inspect. I forgot a T. All right. Now you can see here we have a name, directory, full path, and if we inspect the type with get member to see all its functions, we see that we have a method to set its icon. So let's set its icon from our project icon. Let's see, it's the icon path. Icon, Okay, so the icon is located into the project directory, and we append the rest of the path. Yes, that's all for our shortcut from the shortcut application shortcut folder. Let's create another one for desktop. It's pretty the same thing. The only thing I want to change here is the target directory, which is desktop. All right, run again. Okay, now let's set some general information about the application installed by the package. To do that, we use product details property to access the name of the product, and we just set cool project. Now we can set also the publisher, publish. And since we create, every time we run the script, we create a new project, we will have a different upgrade code. So in order to have a unique upgrade code, we must specify it right here, project.product details upgrade code, and give the unique identifier for the upgrade code. In order to do that, let's get the current one. So that's our upgrade code. And
this is to allow our packages to upgrade previous versions, right?
Yeah, it's Windows installer stuff. We must handle this kind of details. Yeah, for package version, I noticed that a lot of people want to synchronize it with the main executable file. So why not doing that from PowerShell script? Okay, to access a package version, we access to product details version property, and we will set from using PowerShell get item instruction. And we want to use our main executable file, which is this one that we filtered earlier. And from our object, we need the source path. And to that, we need version info and file version, and we need it as a string. That's called toString method. All right, let's run our product details instructions. Okay, now everything is fine. And we can move forward to configure our application service. To do that, first we must filter our project files to get the service file. Okay, in order to do that, we can copy paste the code from our exe file, only this time we call the variable service exe file, and the file name will be called cool project service. Let's run and check our service exe file. Okay, seems to be a problem. It's a type. Okay, it was a type. To create a service install operation, we can go project.services dot new install operation. Let's see, its argument is only a service source file, which is the one we identify above. Okay, and let's put the service install operation in a variable to see more information about this type of install operation. Okay, let's run the instruction. And we can see that we have a lot of members here. I have a name for our service, an operation type that specify what's doing, a display name, which by default is your service. And we should change the display name. So service install dot display name and give it cool project service. All right, let's run. And that's almost all our project configuration. We only have to save our project using save as method. And we will want to save in the same folder as our script file. So we use ps script root, which is a predefined variable in the PowerShell. And we append the name of the file, which is setup.aip. Let's run. Okay, no worries. This is because in the beginning, we saved the file in the same directory. So for some reason, Visual Studio locks that folder. I have no idea why this is happening, but let's continue. After saving our project, we can build it. And we call build method. Okay, let's save. And just a quick restart of my Visual Studio Code instance, I think will just fix the lock issue on that folder. All right, let's run our script again. Okay, seems that our filter on symbol files doesn't work anymore. Yeah, so here we have to do dot.
This is actually a regular expression.
Yeah, I know.
It's not a wildcard expression, so
I know
that's why
what
the
you're
confusion.
saying. I was expecting the same thing you mentioned, but I don't know what's the implementation, what they choose that this implementation. Yes, I expecting to work with .pdb in the end. Okay, now that our script works fine, runs, we can see that our project built and the package resulted is in this path. We have here a build log. So we can launch our package. All right. Okay, let's install. Next. Now that we installed our application, we can see if our service was installed. So for this, for getting all the services with a wildcard, this wildcard applies to the service name. We can use this instruction, get service on this wildcard. So we see our project service was installed and running. If we uninstall our package, let's run it again and just remove. Now we should see that our service is not installed and running anymore. If we run the same instruction again, we see that there's no service. Right now, I want to show you what we created in the end. So this is my setup folder into the project. We have setup files here, which is where our MSI was built. And here we have our project that we generated from the PowerShell script. And we can load into our UI and see some details regarding digital signature, files and folders. You see the folder structure here, as we mentioned in the script. We see the shortcut on desktop, and we set the icon, a custom icon from our resources. And we should see in application shortcut folder another shortcuts. Okay, now everything seems to work, and we can try to go to the next part of our demo, and that will be creating an Azure pipeline. Okay, so here's my Azure DevOps School project, and here are my existing pipelines. If this is a pipeline created previously for the release configuration. So as you see here, the build configuration variable is release. We have few tasks for building, for advanced installer tool, which will install advanced installer on the Azure machine. There's a task for downloading a secure file, because we cannot add, for security reasons, we cannot add the certificate file in our repository. So we must place it in a safe place. Okay. And that's a library here. We have secure files where we can upload our certificate. And we see that we have our certificate here. We can begin configuring a new pipeline. So let's do it. We select Azure Repos Git. We select our project and the type of our application, which is .NET Desktop. As we see here, Azure already generated some pipeline with some tasks, but we don't need every task that was generated here. So let's remove test task and NuGet, since we don't use any nuggets in our application build. Now, let's tell you about the tasks that we need to add into our pipeline. First, the Advanced Installer tool, which is, as I said earlier, is installing Advanced Installer and register it. We need download secure file task, a PowerShell task which will run our script, a task for publishing build artifacts, because we need to download our MSI file, and download build artifacts task to get a link to that file. Okay. So in order to configure all these tasks, use assistant. I use assistant and add an advanced installer tool installer. Okay. Now here we have a checkbox that enables PowerShell automation. We should check it. And here need a license key for our advanced installer tool. And to do that, since our license key is a sensitive information, we should store it into a variable, and we can select keep this value secret. Let's name our variable like this, AI license key. And the value, I will paste it from my password manager. Okay, we defined the license key. And another sensitive information that I would like to mention, and we will use later on configuring the PowerShell script execution, is our certificate file. So let's store our certificate password. For certificate password, we define a new variable Of course, keep this value secret again. Let's call it cert path, and I will just type the password here. Okay. Okay, and for our advanced installer tool, we can use the variable with for the license key. And that's the syntax for configuring Azure pipelines for accessing variables. Okay, now let's add a task to download our certificate file. And our file is crt.pfx. Okay. To get the path where the file is downloaded, we need to assign a name to this task. So let's call it like this. And now we can add a PowerShell task to run our script. Okay, we must specify the script path, which is relative to the root path. This one. Okay, and we must not forget about the arguments with is config, and for configuration we will use this Azure pipeline variable. Okay, and for certificate file we will use the one that is defined like this. Is the Azure syntax for getting the source path. The certificate file is secure file path. Okay, and okay, we have an issue. This is in our script we use the environment variable to extract our certificate password. So in order to have that password, that variable inside our execution, PowerShell execution, we must specify the environment variable for the certificate password. So let's do that. We just hold certificate pass and we can set it from our secret variable. Right. The next task we need to add is publish our artifacts, which will be our MSI package. We need to specify the path we need to publish, which is setup. I should show you from where I wrote this path. So is this path. I should copy paste just to be sure. We should give a name to the artifact, and I will name it, let's say, package. And add the publish. To have a link from where we can download the published artifacts, we can add the download build artifacts task. So Here, I only need to specify the name of the artifact, which is package. So that's all for our pipeline configuration. Add our pipe, save and run. Okay, it's okay. Seems like we need to permit some, we need some permission for the certificate file, which is a secured file. So just hit permit, and we need to wait for Azure to assign a build agent for our pipeline. Let's see. Okay, seems like the pipeline is started. Few days ago, I waited like 2 hours for my pipeline to be executed.
All right, so now from what I can see, the advanced installer task is running and it's being installed on the system.
Advanced installer was registered using the key in the secret variable, and now the PowerShell script is running. Since that there was no problem, and now we have a successful pipeline. And as we see here, we have a link to download our artifact. Let's hit it. And here's our package. We can download, we can open, and here's our MSI package. That was pretty cool. And that was all the pipeline configuration for running PowerShell scripts for advanced installer automation.
Let's take it back to the slides. Thank you, Alex, for that cool demonstration. Those were some nifty things that you've shown us. This brings us to our last part for today, but before that, let's do a quick recap. You've seen a brief introduction to the automation abilities of Advanced Installer, the CLI support that we offer, and most of all, the component object model interfaces that we expose. You can find them online, a list of them of the features that we support using COM at the link shown in this slide. As seen in the demo that Alex just did, using these interfaces from PowerShell is a complete breeze, and they give you very granular access, and you are free to use .NET as you wish. You've seen a few more complex expressions being written there, or using pipes and composing multiple commands, things that are not easy to accomplish in a traditional command line interface. But in PowerShell, we have the freedom and power to do such things. And you can combine the power of Advanced Installer with the power of PowerShell. And this increases your productivity, from project creation to file manipulation to configuring a digital signature and actually building and retrieving your packages. Alex has shown us how quickly you can set up an Azure DevOps pipelining system that seamlessly packages a .NET application using advanced installer automation tasks. And the pipeline that resulted was a smooth experience that generated a package that's ready to test and use. You can pass it to your QA team and then release it. All right, so now on to the final part, the QA section. Let's see some questions. We have a few posted right here. Most of them were already answered by our colleagues, but I'm going to go over them just to make sure that everybody hears the info. Someone asked if this functionality works with the professional version of Advanced Installer. Regis asked this. And yes, this works with the professional version of Advanced Installer. Another question, if an existing project can be used instead of every time creating a new project in the pipeline, like we've seen in the demo. And yes, this is most definitely possible. You can simply load your existing project and add the changes that have been made. We exemplified creating a new project because we feel that this offers more learning opportunities for a demonstration, as you can see how the sausage is made from beginning to end. Another question regarding the a place for where we have documentation on the available APIs for COM interfaces. This was mentioned in the previous slide here. You can check out our user guide for PowerShell automation. And looks like we have a couple of questions about YubiKey, if we support that scenario and if we offer documentation for it. This is a highly requested feature on our support forum, and it's a difficult scenario because you need to enter the YubiKey pin when you sign something with YubiKey, and this turns out to be not a trivial task to do, to enter that pin in an automation environment. And we've worked on that based on the feedback that we got from our customers and try to provide a UI automation process that can help you to uh, get your PIN entered and continue with signing. I'm not sure if this is actually live or it's still in progress. If YubiKey is something that you're interested in, please do contact us, and we'll provide you with further details on this and the current status of our support for that. I think that about wraps it for questions. There is one more that's stating that I am assuming that there are template files that can be loaded and then just update information that changes. I'm guessing that this refers to the project itself. We've answered that before in the initial questions. Yes, you can have an already saved project that you can simply open and then update the information that has changed. And that's about everything. We hope you enjoyed this webinar and found the information presented here to be useful. If you have any other questions or feedback, we would love it. And please use the address provided here, support@advancedinstaller.com, to reach us. And that's it for that. We wish you a good day. Thanks for being here with us today. Bye-bye.